All right, I'm going to walk us through the first example problem in the kinematics lessons. Here we go. Car starts from rest, accelerates at a rate of 5 meters per second for 20 meters. Determine the speed of the car at the end of the 20-meter interval, and determine the time it takes for the car to reach the end of the 20 meters. Pretty simple stuff. The same process that we're going to use for these problems are the similar process that we used for the force diagrams, right? Start with drawing a picture. Draw a picture. Car is over here. So let's draw a picture of a car. Maybe. I'll draw a picture of a car. There's a car. Car is over there, and the things you're going to want to put down here is going to be its position, its time, and the velocity. We'll call this position 0. We'll call this time 0, and it starts from rest. So the fact that it starts from rest, initial velocity is 0. The car travels at some point in the future. The car's over here, and the car's got a changed in position. It says it goes for 20 meters, so its changed position is 20 meters. We want to know how long this takes, and we want to know what its speed is going to be at the end of this interval and throughout this entire trip. Throughout this entire trip, the car was accelerating at 5 meters per second, or 5 meters per second squared. This is the picture. This is the way to draw it. Now, you figure out what do we need? We need to know speed at the end of this. So we need an equation with final speed, or Vx, right? Well, look at this first one up here, this top equation. You get V final equals V initial plus AT. Well, that's not very useful to us right now because we want to solve this, but we also don't have time. So we have two unknowns. Can't use that equation. Then we want VF, so we better use the equation here. VF squared equals VI squared plus 2 acceleration times the distance. Well, this might going to work. VF squared is what we want to know. VI is 0 plus 2 times 5 meters per second squared times a distance of 20 meters. Do all this arithmetic. VF squared equals 10 times 20, 200. Right? 2 times 5 is 10. 10 times 20 is 200 meters squared per second squared if you follow the units across. So VF is equal to the square root of 200 meters squared per second squared. The square root of 200 is probably something like, I don't know, do the math. 200 square root 14.14. So VF is equal to 14.14 meters per second. That goes here. That's pretty simple, I hope. Now that we know VF, or the V at this change of position, now we can go back to that first equation. VF equals VI plus AT. We now know the final velocity was 14.14 meters per second. Well, that doesn't even look like 14. Yikes. Erase that. 14.14 meters per second equals initial velocity was 0 plus the acceleration of 5 meters per second squared times time. Divide both sides by 5 meters per second squared. 14.14 divided by 5, 2.83. 2.83 seconds. Our meters cancel out with the meters. One of these seconds cancels out with one of those seconds, and we should get our time left in seconds. 2.83 seconds. Problem solved.